Okay, in this you have to find the absolute extrema of f and where they occur, and find any points of inflection. It says that f is continuous on 0 to 3. You have these little data boxes. I hope you can see them. They're a little small, but and so you just got to find these two things. And for 2, you have to sketch a graph of f that passes through point P. So there's point P. This is f prime. This is f double prime. So, I mean, you just got to figure that out. And so pause now. Alright, hopefully you didn't get stuck. Now I'm going to show you the solutions. So, for number 1, there's a max at 1 because f prime at 1 is 0 and f double prime at 1 is negative, so we learned that before. There's a minimum at x equals 3 because it's an endpoint, which thanks to the extreme value theorem makes it either a max or a min, and since f is negative, it means that it's a min. And there's an absolute max at x equals 1.
Hi, so I'm going to talk about the second problem. This is your original problem. You got your f prime graph here, and the second derivative here. So the function graph looks like this one right here. Right here. Alright. So why is that the case? Well, we have the first derivative is 0 at these points. So whenever it's 0, we must have a max or a min. And for the second derivative, when that's at 0, we have a point of inflection on the function graph. Well, why is this a graph? Well, we know that this is a point of inflection because whenever the second derivative equals 0, it is a point of inflection. Easy. But why is this a max and why is this a min? Well, like we did with the toolbox with the number line, whenever from the left it's increasing and to the right it's decreasing, we have a max. As you can see, it's becoming less positive, and then we have 0. We have a change in signs because this is positive, this is negative. So when at the point where it changes signs, it's either max or min. And in this case it's a max because it's going positive, and then here it's becoming negative, so it's got a negative. Alright, so then we come to this point, it's still negative, and then right here there's a sign change, and it's becoming positive. So right at this point it's becoming positive. So that is why we get the function graph from the first derivative and the second derivative. Hope that helped.
This is about the extreme value theorem, EVT. This one's pretty self-explanatory, just which case satisfies the requirements of the extreme value theorem, it says right there. And you're given choices A, B, C, D. So, pause now. Alright, hope you didn't get stuck on this one. I chose A because f is continuous on a closed interval, as you can see by this, continuous, and 2 solid dots, closed interval. Now it can't be B because this isn't a closed interval. On one side it is, but on the other side there's a hole. This one, there's a hole in the middle of it. So, I mean, other than that it would be good, but... And this one is not a function because it's a circle. It doesn't satisfy the vertical line test. So I hope that helped. Thank you.